Welcome to today's webinar, Get Smart. Use simulation to accelerate API testing. I'm Joy Ruff, the Product Marketing Manager for the Enterprise Continuous Quality Suite at Parasoft, and Wilhelm Hocker, our Senior Solutions Architect for the Parasoft Automated Testing Platform, is here with me today. Many organizations are working through digital transformations to improve their ability to deliver high-quality applications, which in turn is driving the need for them to innovate in order to provide a compelling customer experience. These initiatives are driven by market drivers, including the desire to be the first to enter a new market, moving toward the use of service platforms for new market potential, and focusing on satisfying customer wants and needs for an optimal user experience. With disruption in nearly every market, competition has significantly increased. The increase in offerings means that customers can make a switch to another vendor faster and cheaper than in the past. So providing a strong customer experience is crucial to a company's business success. Cost control through innovative optimizations also ranks highly as a driver for modernization. The path to improving software quality requires modernizing both your software development methodology and your testing strategy and processes. There are many areas for consideration that can be part of your modernization strategy, such as implementing Agile and DevOps workflows, continuous integration build processes, adopting cloud deployments, containers, and microservices, diverse user interfaces for multi-channel interactions, multiple or more frequent software releases, test automation with a push to continuous testing, and shifting testing along the entire software development lifecycle for comprehensive coverage. Perhaps you've started along this path, but haven't transitioned completely to a fully mature DevOps deployment with all these characteristics. Some of these are big changes that do require a specific strategy and plan for transformation to these modern elements. Roughly 90% of the projects we are brought into aren't greenfield development projects where teams have the luxury of implementing best practices from the start. We work with many organizations doing brownfield development that are seeking a partner to help them digitally transform. A successful modernization effort combines a lot of things. To modernize your legacy development environment for continuous software delivery, it's essential to invest in a software development practice that combines people, processes, and technology. The people are the most important component with their expertise and domain knowledge. They are the key to enabling the organization to succeed at both communication and collaboration around the new processes. These modern processes involve iterative and agile approaches rather than the outdated monolithic waterfall model. Development is done quickly through a sprint-based schedule that encourages frequent feedback and faster cycles. The only way to make this new approach work in an efficient way is through automation. You want to automate as much as possible for your delivery with helpful technology to get the functionality into production with confidence that you've built the right product for the right people. So how does testing fit into this picture? First of all, with regards to people, you must encourage teamwork in a quality-first culture for dev and test to work well together, not dev versus test, where things are thrown over the wall without any communication. Additionally, testing should be included in sprint during the development process, not left until the end of the cycle. By correlating the coding and the testing to the user stories, you can optimize testing practices to get rapid feedback and respond to it. And the next step is to enable your tests to run continuously using API testing and service virtualization to ensure that any testing bottlenecks are removed, allowing the DevOps team to complete each sprint successfully. The technology is what enables the people to build an effective process and implement a successful transformation. When selecting what technologies to deploy, it's important to gauge whether the tools you're considering are aligned with the overall modernization driver you have. You need more than a collection of tools. You need a platform that helps you identify, manage, and analyze the data coming out of your process that helps guide your people to effectively follow the agile tenet of continuous improvement. Many companies are recognizing the importance of software quality and raising it in priority in their organizations. Here are just 3 examples of industry leaders, name brands you're likely familiar with, that have brought quality to the forefront of their investor conferences or annual reports. They're all trying to differentiate and capture new markets while delivering innovations. They've realized that if they can't deliver high-quality innovations, the business isn't going to be successful. Quality has become an important topic at the senior levels of the team because it affects the entire organization. So, why the focus on quality? The impact of modernization without attention to quality will result in an acceleration of technical debt and undesirable business outcomes. Poor software quality is still a significant contributing factor that results in unsuccessful projects. In 2020, the SysQ report estimated that the cost of poor software quality on just the US economy exceeded $2 trillion. The challenge is that in many organizations, testing has not kept pace with the maturity of the DevOps processes and other aspects of agile iterative development. Your organization needs to pay special attention to technical KPIs resulting from your automated processes to ensure that quality, security, performance, and business risk are managed proactively instead of discovered at the worst moments. And it's the entire organization that is now looking at quality. Several industry surveys and analyst reports have highlighted these considerations. Quality has become a primary driver for the key metrics that development teams are using to measure their success. The top two items are increasing test coverage and reducing defects in product. You might think that developers would be more focused on the completion of user requirements and features, but their definition of done isn't just what does it do, but also does it work? According to the famous work done by Capers-Jones covering the economics of software quality, we know that finding and fixing problems sooner has a significant impact on the cost to remediation of defects. Agile is not just about detecting defects, it's about seeking optimizations that allow you to detect them as early as possible where it's cheapest to fix. And that is the true difference when choosing Parasoft as your partner. But it's not just the development team. Business leaders are also looking at quality as a strategic business requirement to ensure that they're successful at delivering higher level business objectives efficiently. Almost half consider quality improvement one of their top 3 priorities, and over 2/3 are also looking to build in quality at a faster rate to accelerate the delivery of high quality customer experiences. These key drivers are recognized by Forrester in their recent Tech Tide report. They talked about how continuous software delivery is critical to making your organization successful and meeting customer expectations. To be more competitive and disruptive, you may need to retool your entire tool chain, as well as leverage your resources and your culture to achieve these goals and deliver true value to the business. Forrester also noted that testing tools are a key area for investment that provides great benefits to the organization. There is a cost involved in doing these things efficiently and effectively, but the return on the investment justifies the expense. There are 3 goals that we are seeing that are being pursued to reduce the cost of quality, security, and compliance. To be successful in the delivery of your projects in the most cost-effective way possible, you need to test earlier. That means shifting quality and security to the left within sprint testing to deliver on these priorities during code development. Developer-led testing practices like static analysis and unit testing have a transformational impact on ensuring the interrelated priorities of cost, quality, speed, and business risk are managed. Furthermore, the inability to perform integrated testing early in your process can be another barrier to accelerating the successful delivery of software projects. Tests should be run in an automated way as developers are implementing code. The definition of done includes completed features and functions that are tested automatically. This will make it easier, cheaper, and quicker for you to remediate any problems found during the sprint and throughout the development workflow. As you continue to apply and execute those tests continuously, you can find problems earlier, which takes us to the second step: test faster. If all you have is a hammer, every problem begins to look like a nail. Organizations struggle with optimizing their testing strategy to fit within the parameters of Agile, and the inability to accelerate can stem from a variety of places. For example, a functional test at the UI layer will always be slower and more expensive than testing that same functionality via APIs. Organizations need a platform that enables them to efficiently build the right test, not just a test. With continuous automated testing across your release train, you can validate functionality as you go and get immediate feedback when any defects are introduced. Lastly, you need to test less. As an organization's maturity in automated testing increases, so does the volume of testing that takes place. Having more tests does not necessarily equate to higher quality, but we know for a fact that it equates to a higher maintenance burden and a delayed feedback loop to development. So while it may seem counterintuitive, Agile also means being smarter about what tests you're running, regularly reviewing the measurable outcomes of your quality process, and seeking opportunities to prune the tests that are no longer relevant or valuable. Enabling testing practices with the right tools is one aspect of a successful transformation, but the other, often overlooked aspect is having a platform that highlights the KPIs coming out of these practices that can help your teams continuously improve. The key to this is making sure that you can run your tests continuously through the DevOps pipeline. To enable true shift left and unlock the benefits of Agile, you need to start in the planning phase. This is where you set your baselines and policies that govern the change-based optimizations that enable in-sprint testing. The coding phase is where 85% of defects are introduced and your first opportunity to begin detecting them where it's cheapest to fix. Parasoft's developer-oriented tools enable customers to run static code analysis, save time unit testing, and collect code coverage metrics within the developer's daily workflow and CI/CD process. The build phase is where code is packaged and prepared to be deployed for black box testing. Service virtualization is used to help organizations scale and stabilize the environments that allow them to test without ballooning the operations budget for cloud and other infrastructure expenditures. The testing phase is where UIs, APIs, and other interfaces and workflows are exercised in Sprint to determine if they meet functional, reliability, performance, and security requirements. The release phase is where traditional approaches will complete non-functional testing to ensure the sprint is ready for deployment. With Parasoft's continuous quality approach, the majority of the work has already been completed, allowing you to accelerate your release cycle where traditional approaches may simply validate that your process works. The remaining phases are where customers leverage Parasoft's analytics on the technical KPIs of the Agile process to conduct policy checks and adjustments, which are fed back into the next sprint's planning cycle. So here's how the Agile community recommends architecting a continuous testing strategy, which we wholeheartedly agree with. The testing pyramid is designed to show you where you should be spending your time and how many tests you should be running at each layer. At the base of the pyramid is a foundation of unit tests, backed up by a solid set of API or service level tests. These tests are more efficient, so you should have more of them to achieve broad coverage. These tests can be created earlier in the software development process, are easier to automate, easier to understand, and ultimately easier to diagnose the root causes of regressions and test failures. The upper half of the pyramid, the best practice is to focus. Seek opportunities to automate what is manual. Test the backend functionality directly via APIs, and focus UI testing on client-side logic and user journey, as UI tests are difficult to automate, take longer to run, and must wait until the entire application and test environment are available. They're also difficult to maintain and difficult to diagnose when defects manifest. There's a missing layer to this pyramid, which is at the code level. You can't build quality into an application by doing a lot of testing. You need to have a quality-first approach during requirements and development, and code analysis can help address the deep reliability and security issues, as well as identify and prevent those problems from occurring in the first place. Following this pyramid as a blueprint helps you create a test automation strategy that is scalable for enterprise applications. Everything in the testing pyramid should be used to validate and verify code and address defects within the use cases. However, when we talk to actual organizations, most of them have an inverted pyramid that resembles an ice cream cone or perhaps something more like a martini glass. We find that many organizations are skipping right past the API testing because it is harder to understand and it often falls into a no man's land between developer and test teams. Bottom line, a lot of companies are still struggling with achieving automated testing and extending it to continuous testing. So, to deliver these new software capabilities and complete application testing in a timely manner, you need to have a CI/CD pipeline that incorporates CT, continuous testing, with test automation. So, what are those primary challenges or obstacles when you're trying to move from an incomplete testing strategy to automated testing and then maturing into a continuous testing practice? There are three things that we can quickly identify. First, the expertise of the team is a key factor. If the team is more focused on manual testing, they will need to gain new skills to take advantage of automated testing. Then, with execution, teams often face instability in their testing. Tests may fail when something changes in the code or the environment, and diagnosing those problems can be time consuming. Lastly, the main thing that prevents testing strategies from reaching the continuous testing goal is the test environment itself. Not having access to or control of back-end system dependencies stops teams from being able to do testing validation earlier in the process and from being able to complete testing within designated sprints. Those constraints negatively affect the reliability and execution of your tests. So let's go into each one of these areas in more detail. Regarding expertise, there are several common areas or practices that may be included as part of your test automation strategy, including UI, API, and non-functional testing. The goal is to simplify test automation to enable the team with the right types of training, expertise, and tools so that they can so that they can do their jobs more effectively. With UI testing, Selenium is the primary web UI test automation framework. This open source solution does take some technical knowledge to use effectively. And to simplify and extend test automation for UI testing with Selenium, you can use a tool that supports recording and automatic test creation to help you create reusable and repeatable tests that are easy to maintain, having been organized with the best practice page object model design pattern. For teams of existing Selenium users, Parasoft Selenic is unique in that it plugs in directly to your Java-based Selenium projects with no migration, translation, or loss of your existing work. As I mentioned earlier, API testing is kind of the sweet spot in the testing pyramid, even though it may be tossed like a hot potato between the developers and testers. The number one challenge when organizations are trying to adopt API testing is understanding how the APIs are actually used. API documentation helps with governance and security guidelines, but may not have information about how they interact or are used in a real-life scenario or use case. Use a similar record and automatic test creation approach to understand how each API behaves and how the APIs interact with each other, so you can create useful test scenarios that reflect actual use cases. Non-functional testing may include load, performance, and security testing, which are used to identify potential defects under specific conditions. By shifting this testing left, you can reduce the development rollbacks, disruptions, and delays for defect remediation. Waiting for this feedback late in the release cycles does not align with modern development practices of short iterative cycles. It leaves too much business risk exposed. Leverage the functional testing suite to scale for non-functional testing needs and enable continuous testing to identify and address problems before they can cause a serious impact to the software schedule. When we talk about execution, I'm referring to what it takes to make the tests run and run reliably. First, your application isn't static. Changes in a sprint could significantly impact the user interface or the application workflows. Make sure those changes don't introduce instabilities into your applications, and if they do, you want to address them as quickly as possible. Artificial intelligence integrated with test execution helps to address these issues. When changes introduce instabilities, AI can detect that a change occurred, adapt the test to manage the change, and update the test wherever needed to ensure it works properly. This makes your tests easier and quicker to maintain. And as your test suite grows to hundreds or thousands of tests, your execution time increases proportionally. How can you optimize the execution of those tests to get feedback as quickly as possible? Testing as much functionality as possible at the API layer instead of with UI testing is one obvious optimization. Moreover, AI can identify the changes in the code and correlate those back to which specific tests need to be executed to verify just those code changes without rerunning the entire suite. This can significantly reduce the time of in-sprint test runs. And lastly, when your tests execute and do result in failures, you need to understand the context of the test failures. Not all test failures are equal, and not every use case isn't as important as others. Maybe the test is unstable, or maybe something changed in the API itself. If you don't understand what the impact of the test failure is to the business, then it can detract from the test automation strategy. By correlating tests to code coverage, as well as back to the user stories or business requirements, you can ensure that business risks are uncovered early and efficiently before they impact your release schedule, or worse, blow up in your face as a headline. The test environment can be the gating factor that prevents organizations from transitioning from automated to continuous testing. There are 3 types of problems that organizations face when trying to run tests anytime, anywhere. It's related to the external dependencies of the application, especially in a highly distributed microservices world. Service virtualization helps to address each of these issues. For some shared systems, such as mainframes, you may be limited to specific time windows for access because the business is trying to control operational costs. Use service virtualization to create a simulation by recording a live system and modeling its behavior. Once you have a virtual asset, you can dynamically choose between the live and virtual version of the service to test against, thus unblocking yourself from lost my place. So yes, once you have a virtual asset, you can dynamically choose between that live and the virtual version, thereby unblocking yourself from scaling up your testing due to budgetary limitations. With multiple teams working in parallel, there could be a bottleneck if certain parts of the system aren't yet available. By using a virtual prototype, you can model the expected behavior based on the service definitions or other information and use that before the full services solution is deployed. This addresses the inevitable efficiencies that can creep up when you're orchestrating the deliverables of many teams working in parallel. These delays add up as overhead to be stomached as the cost of doing business, but can be avoided when service virtualization is implemented. There's an uncontrollable environment that's difficult to configure for accurate usage because of the data, the functionality, or the performance characteristics. With synthetic data, you can model and create safe data that won't be impacted by any PII or GDPR constraints. Service virtualization is a key optimizer for traditional test data management, where users can expect slow data refreshes that come with a significant cost. So we have reviewed ways to address the challenges to achieving continuous testing, the team's expertise, how to reduce the technical challenges, test execution, how to make it faster, more reliable and stable, and the environment, how to get full control of the test environment. Now I'll hand it over to my colleague, Wilhelm, and he will show you how Parasoft can help you reach these goals.
Thank you, Joy. So when organizations are researching and planning out the processes that they want to modernize, the starting point here is often a collection of disparate tools to test different things. And in some cases, specialized performance and security teams will use specific tools for their late cycle certification prior to a release. But shifting these testing practices left is difficult because there's going to be resistance to adopting so many tools in the agile workflow. These teams are already dealing with enough tools to begin with. So Parasoft's value here is acutely felt because testers can now perform functional testing, omni-channel testing, as well as non-functional testing, all from one unified test framework in Parasoft SOA Test. And in our previous webinar titled Fuse AI into the CI/CD pipeline to optimize Selenium testing, we had a focus on testing the UI layer. So today, we're going to pick up where that webinar left off and focus our attention on APIs. In fact, we're going to be leveraging a Selenium-based UI test created with Parasoft Selenic to help us bootstrap the API testing practice. Next, we're going to see how these functional API tests get reused for load and performance testing, as well as security penetration testing. And this speaks to those shift left goals with our customers' modernization initiatives. Then, we're going to touch on how AI helps reduce the maintenance burden of your API testing practice that's going to be impacted when development makes changes to those APIs. Then, we're going to look at optimized test execution to see how that test less goal can result in accelerated feedback to development with up to a 70% reduction in build times. And then lastly here, we're going to revisit Parasoft DTP. This is our purpose-built platform that helps our customers manage their continuous testing practices that are going to be part of their larger modernization initiative. So let's go ahead and get started. All right. So the demo application I'm going to be working with today is called Paratroopers. It's a logistics app that deploys assets to various campaigns. And manual tests here can be recorded using our Chrome extension to record API traffic from the UI. But today, we're actually going to start things off by leveraging an existing UI test here to bootstrap our API testing. And while I'm going to be using Parasoft Selenic here to kick off our UI test and record API traffic, bear in mind that SOATest's API recording capability can be integrated with any UI testing framework. So that means Selenium web UI tests, regardless of which language you chose to implement it with. That means Appium mobile UI tests, regardless of which language you chose there as well. And that even means our competitors that offer automated testing frameworks. We built a flexible API-based architecture, so it really doesn't matter how your automated tests were implemented. We can record that API traffic and help you with your API testing process. So we'll go ahead and do this. I'll kick off this test and we will go over the use case here that we have automated for Paratroopers. And once the browser comes up, I'll drag it over for us all to see. There we go. So we have two users. There's a purchaser user that comes in and is adding some, in this case, some troops to a requisition. And these troops are going to be going to the United Kingdom. We're assigning a campaign here with some information. And then submitting this for approval, where another user, the approval user, is going to come in and make some changes to the data here, right? We're updating the status of this to be approved. Now we're going to come back in as the purchaser. We're going to go check the status of our requisition and see, oh, look at that. It's been approved. And so one of the aspects of an end-to-end scenario like this is there are going to be many APIs that get called by the UI to facilitate that whole experience. And so what we have is now the ability to capture all that traffic and process it to produce a test here in SOATest. So we're looking at Parasoft SOATest right now. And this is our framework for integration testing, API testing, It's our Swiss Army knife for your end-to-end testing needs that may span multiple channels like omni-channel, multi-channel testing. And one of the nice aspects of it is we have a nice UI where testers don't need to have coding skills to necessarily work on testing APIs. And so here we can see there's quite a few API requests that got made by the UI, right? Logging in, getting some data to present on the page. Here on test 20, where I opened up our client, this is where an order is getting submitted. So it's when our purchaser made the order. Then we can see log out, log in. So these steps are related to approving that requisition. And then finally, the last login, this is where our purchaser logs back in to check the status of their order. And one of the things the AI does here in SOATest to make things much easier for us to develop this kind of script is it's analyzing the recorded data from these API calls, and it's looking to see if there's any relationship between the data that would result in the test not working because it's hard coded. And so you'll notice here, test 37 has the order number parameterized, where the order number is coming from this post request where the order first got made. So what our AI was able to figure out is that this order number coming back from the post request was necessary for subsequent calls later on in the scenario. And so it automatically extracted that order number for us and then parameterized the necessary tests. And this is really where the big time sink comes in for developing these types of scenario tests at the API layer. There can be a lot of interrelated data like this that you need to factor into your test scenario to make it work properly. And so the AI here helps us save a tremendous amount of time, not just to get this to run, but in fact, we also look for opportunities to automatically add assertions. Like, for example, we know this reviewed by purchaser field. This field is changing over time, right? It originally starts as false. Now it turns into true. And so we detected that and said, hey, because this is changing throughout the scenario, the user might want to set an assertion so that we're checking that it's changing the right way. So a lot of speed up in terms of the test creation process. But let's think about why this can be so valuable for agile testing and getting feedback to development quickly. So if we take a look here, let's log back in. All right, we can see we've got 13 orders in the system. And I know that our UI test took a little over a minute to run. So let's see what it looks like when we run the same scenario directly via the APIs. And then see that we got a new requisition with the right status, right? And that took a fraction of the time here, 3 seconds versus over a minute. So this can be very transformational to get your functional testing done much more quickly and in a stable way. So next, let's take a look at non-functional testing. So a scenario like this, which thanks to the AI and recording, we're able to rapidly develop. Let's take a look at Parasoft's load test solution, which is integrated with SOATest. It's part of SOATest. And so here we can see I can define my load test parameters to even scale load from multiple machines. This can be important if you're trying to drive load from different data centers and review response times and things coming from different geolocations. And one of the unique things here with Parasoft is we enable the functional data validation during performance testing. So you can disable that if you want to get more juice out of your load generators, because it will have a performance impact. But the nice thing here is you can start verifying that the functionality of your APIs isn't impacted when they're placed under load, which is quite a cool feature to be able to do from performance testing. We can see here is our scenario that we've got with those APIs from Paratroopers. And I can go ahead and define my load test. So in this case, I'm just ramping up to 5 virtual users, running it for a little while, and then ramping down. And you can provide your expectations on the data collected during your load test to make sure that the SLAs for your systems are being met. Things like response times, even monitored metrics. In fact, you can connect a lot of monitoring to your load test. Maybe you have APM technologies that you've already deployed in your environments to do that. We have various other mechanisms to get monitoring data, even monitoring threads from a Java JVM. And so all this ends up with being able to automate this as part of your CI/CD pipeline, running it early and regularly, and getting some feedback on performance degradations that may be happening. So for example, we can expose statistics detailed down to all the individual API calls that your scenario had. Or maybe you want to see the statistics rolled up for the entire scenario itself. And you can really start exploring what the data means. So for example, here we can see an interesting correlation where throughput is going down while average execution time is going up. If I make this logarithmic here, we can see it's pretty closely aligned to increasing the concurrency on paratroopers here. So we've definitely got some scaling issues that the application developers should look at, because I doubt paratroopers would be able to handle a large volume of users trying to access it all at once. Now, of course, when it comes to analyzing trends related to performance, you want to be able to compare multiple reports together. So we offer a web-based interface for that comparison. But right now, I'm just going to show it to you from the tool itself, where you can load multiple reports and start comparing how the output of that data differs between those runs. And this comparison, like I said, can be added to a web-based dashboard, so you can review these things easily from the browser. All right, so that's performance testing real quick. I also want to spend a short amount of time here going over security penetration testing as well. This is often a hot button issue to shift left the detection of these issues. And so we can enable our customers that are doing functional testing of their APIs to very quickly add penetration testing to their scenarios. So Parasoft SOA Test has a built-in integration with OWASP ZAP, which facilitates those attack scenarios. And we also have an integration with Burp Suite for any customers that are customers of Burp Suite. And so when we run a scenario using ZAP here in SOA Test, we get to see all the various attack parameters that ZAP was helping us drive here. So for example, say you're interested in seeing the SQL injection runs. There's quite a few that get sent out. But more importantly, when you're running this type of testing, it's important to understand what the output means, right? So what we've done with the data coming back from ZAP is integrated it into our reporting framework. And we have a lot of very useful data for these detected issues that link back to the CWE. So you have a clear connection between what this failure means and what are some of the common remediation strategies teams take to address issues like this. So if we take a look at an one that I thought was pretty interesting here is detection of sensitive information being exposed. And so I can also see what the associated traffic is here. And if we look at the request, sure enough, we're passing usernames and passwords here. They're unencrypted, and so this is a pretty relevant finding. And so the data from this security testing will also be available in SOATest's output reports. So here we've got an HTML report. We've got the usual suspects, your API coverage, details of test failures. And then here we have a section related to API security. So there's a clear understanding of your security risk that's coming out of your in-sprint testing when you've shifted left the security testing down to the testers so they can start exposing this earlier where it's easier to do something about it. All right. Next, let's take a look at the topic of test maintenance. And so one of the facets of SOATest here is another application of AI. So as testing practices mature, so will the number of tests. And this can place a burden on testers to keep their test suites current when development starts accelerating the pace of change to APIs. And so if your development teams are following API development best practice and implementing service definitions like Swagger or RAML, then you're in great luck. So what we're about to see is the power of AI again, but this time in service of reducing the time it takes for testers to update tests when things are changing. So I've got a series of tests here. And in this case, it's a SOAP web service. It's a legacy system that's currently going through some change. And I have a test scenario here where I've got it nicely set up for version 1. All my data is nicely parameterized. But now development sent a new version of this service, V2, where they've changed the structure of the messages, the schemas are different. So if I switch to that new version of the service, I can see that it's resulting in my test breaking. Right? If I take a look at this book element here, we can see there's this genre field that wasn't there before. Product info looks important. That's not configured at all. So now I have to go do some work, right, and fix my tests for the new version of the service. Well, let's see how SOATest makes my life easier here. So what we can do is perform a change impact analysis, which means SOATest is going to analyze the tests you have for a specific version of the service, and then it's going to detect what are the differences between those versions of the service that you need to go address. And so I don't want to manually address these one by one. So what our Change Advisor functionality lets me do is it lets me define what we call a change template. So I'll call this bookstore V1, V2. And notice we have this functionality both for SOATest test clients as well as virtual assets that respond. So here we're looking at SOATest, and our change template is using AI to automatically infer if it can make that refactoring automatically without any human intervention. So here, all the operations are mapped. Yellow means high probability match. So here we can see that development changed the name of the service. And so I'm a human. I know that's the same thing. Now, if we come back to schemas, here we can see really the differences between the original service and the new service. And you can see that a lot of the fields are in green, which means the AI was able to map them automatically. And then there's some things in red and yellow that I should review. So here it matched price to genre based on the index. But I know that really price belongs here under product info as amount. So I can make that connection. And let's say this is good. And then for genre, maybe since this is a brand new field that didn't exist before, let's say I want to put some default value there so it's not blank. I've set up my template, right? Why did I go through this whole sequence here? Well, it's for the purpose of bulk refactoring, right? I don't want to individually update all these tests one by one. If I have a lot of them, that could take weeks. And in fact, that's what some of our customers have told us, that this can represent weeks of downtime before they can update all their API tests when development makes changes. So we can refactor a group of tests, not even just one test, that all represent testing of this service. And then we'll take a look and see whether this bulk refactoring here will have saved us any time. And so here we can see new test cases are getting added as we go through that bulk refactoring workflow. And so while that's running, I'm going to remind us what it looks like with the broken test here. All right, so here we can see things were broken. And if we come take a look at our new test that was created with that change template, here we can see that everything was nicely connected together and refactored for me. And so when we scale this up, this is where a bunch of time saving comes in. And so maintenance is a key factor in really being able to automate quickly and get those results and feedback to development quickly when things are changing, right? When it's most difficult to give feedback. So that's another key aspect here that I wanted to cover. And so now let's talk about execution. And so here I've got my CI/CD tool Jenkins, where I've got a variety of jobs that I've been running against our Parabank application. And you'll notice here I have one job that took a significantly less amount of time than my other jobs that are running every test. And so for our Java Shop customers, we have an additional optimization here that turbocharges their test faster goal. And so our code analysis allows us to detect exactly which test cases are impacted by the code changes development has made since the starting point of a baseline you set at the beginning of the sprint. And so what this means is commit suites become a thing of the past and build times are reduced by up to 70% because you're only executing exactly which tests are covering the code that developers have modified. Okay, last topic here is DTP. So here we're going to see what all this transformational work really looks like. We're going to see the measurement of the process to help drive that agile feedback loop. So our customers are measuring a multitude of KPIs and advanced analytics that we provide to help them continuously steer and course correct throughout their sprint and release cycles. And so this means product owners and leadership are made aware of what business risks and business impacts are exposed by the value stream so they can make informed decisions. Right? So things like code coverage, being able to capture the code coverage from your functional testing, whether that's at the API layer or the UI layer, modified coverage, being able to determine whether the code that you've modified from your baseline, say that's the beginning of a sprint or the beginning of a release, whether that newly modified code is well tested or not. That's a key driver when you're working in the agile context. And these dashboards are all totally customizable. You can really build up exactly what you want to see from the data that's being published here from across your SDLC. All right, so at this point, let me switch things back over. All right. So now that we've covered the testing side of things, let's address the test environment challenges that Joy described earlier. And so modernization typically isn't just tied to the software development and testing practices. Organizations we're speaking with are modernizing across the board. And so this means we're seeing an ever increasing adoption of API first development, monolith decomposition into microservices, as well as cloud and containerized deployments. And all of this complexity in the deployment of your software introduces additional barriers to continuous testing. Things like freedom of access, control of test data, high capacity and availability for integrations that your tested applications may have with third-party services that could have a cost associated with them. Agile roadblocks from integrations that your applications teams have with other internal services owned by other teams. And so we have all these challenges where service virtualization really comes in to help. It checks all the boxes with the ability to simulate specific conditions and stand up virtualized service and system components quickly. And this simulated test data can be reused in testing, which really allows the teams to test early and test often. So how this all works is we start things off by defining message proxies that get injected in between your tested application and those downstream dependencies. Next, we capture the interactions between your application and those systems while running your tests. And we use that data to help us build a virtual version of that backend system and deploy it to a virtualized server so that you're now ready to disconnect your application from those dependencies. And whether this is a static environment that you want to switch out manually, or whether this is part of some automated process like something in Jenkins or GitHub Actions, you can control whether your tested application is going to be talking to real systems or virtual assets that you've built to help you scale up and start testing earlier. And here we go. And moving into the area of DevOps, it allows us to take a more environment-based approach to testing, as it allows us to model the complex deployment environments where both service virtualization and test automation interact with. And this allows DevOps engineers to effectively collaborate with application teams that are wanting to implement these cost-saving workflows and doing it without placing a high burden on DevOps just to make magic happen with square pegs and round holes. And so Parasoft's solution here is purpose-built to fit into advanced deploy-destroy workflows using the industry's most popular CI/CD tools and integrating service virtualization and test automation with your containerized and ephemeral deployments, making it easy using our API ecosystem and CI/CD integrations to help you clone those virtual environments and run tests whenever you need them. And that data from all your testing gets published to our Parasoft DTP to help the Agile teams manage their priorities and deliver their promise of quality, security, and resilience at speed back to their stakeholders. Okay. And so I just have a short segment here on service virtualization. So I'll share my screen again. And so I have another deployment of paratroopers here running locally in my environment. And what I want to do is I want to test paratroopers completely isolated from the APIs that it typically calls when I perform my testing. And so I'll come in here into virtualize. And I have a traffic file that I recorded from that same Selenium test we saw earlier. And so what I'm going to do is create a virtual asset using that same traffic. So that same scenario we saw. So I'll call this demo total traffic. And let's get that traffic file. And here we have a very interesting workflow. And so similar to how we saw the bootstrapping of API testing, the same applies here in service virtualization. We can take those existing automated tests and accurately capture that complex behavior of the backend APIs your app is calling, and then deliver a fully automated provisioning of a replay environment that's tightly coupled to your tests. And so when you have agile teams that are heavily reliant on automated regression testing, they now have a low effort mechanism to capture the stable behavior of an integration environment and then disconnect from it so that they can repeatedly run their test cycles without worrying about instabilities in the real environment. And so what this really enables is organizations can now significantly increase the scale of their testing because there's no longer this increasing cost to support that high demand from application teams for additional test environments. And so here, I have a traffic template which sort of defines the logic for how virtualized processes recorded traffic. And what this means for me is I can come in and here say that this is the data source that I want created for this virtual service. Here we can see how it's grouping the messages that were recorded. And then I'm just going to go ahead and hit finish here. And so notice all I did was click next, next, and finish. And so what this means is the process of recording traffic, creating the virtual asset, and deploying the virtual asset all can be fully automated as part of your DevOps process. So I don't need any human intervention, for example, to come in here and integrate a virtual service that I built from recording so that I can disconnect from my environment. So I'm going to give my service that we just created here a unique endpoint, and we'll turn it on. And I have a message proxy for this local deployment of paratroopers here. And you can see that I was testing this out earlier. So I want to essentially funnel all of the API traffic from my local paratroopers to our newly created virtual service. Now, before I run our test again, let's make a quick change here so that we can see the outcome on the UI. So let's say approved by Parasoft Virtualize. Right. So now let's come in and run the same test, but this time it's going to my local deployment of paratroopers where none of the backend APIs are going to be called through this test playback here. Okay. Here comes the browser. All right, so data is showing up. That's good. Now we're going through the process 9993. That was the number of troops available during recording, which you may have seen was different earlier in the presentation today. And all the stateful nature of this scenario is being captured as well. Here, when we log in as the approver user, we'll see that the status is open. We make the approval. The status changes to closed. So our virtual asset is truly capturing, that stateful behavior, and I didn't have to spend very much time at all to get it built and deployed. And here we can see approved by Parasoft Virtualize. We know that all of this data that the UI is showing us is coming from our virtual asset. So very, very, very powerful stuff to help you start testing earlier in your cycle. And with that, Joy, I'm done with my part, so I'll pass it back to you.
Great. Thanks so much for that great demonstration, Wilhelm. Our goal here is to help you accelerate the delivery of your applications with true continuous testing. First, test earlier. Test in sprint with the development team doing the initial work and cooperating hand in hand with the testing team to validate the code and automate the testing. Test faster. Use the test automation to build the test continuously, not just in this sprint, but also in the next one to find regressions as soon as they're introduced. And lastly, test less. Optimize the test creation and execution efforts, resulting in lower costs for your automated testing infrastructure. You can maximize your test automation ROI by reducing the cost of validating your software quality, security, and compliance in your DevOps workflow. Going forward, we would like to invite you to attend our upcoming Automated Software Testing and Quality Summit scheduled for November 4th. This half-day event will feature companies from multiple industries that are sharing their continuous quality journeys. And you can find more information and register at the link shown here or scan the QR code. Our session ran long today, so if you have any questions for us about API testing and service virtualization, please send those to us via the Parasoft website, and we'd be happy to follow up with you. And if you're interested in getting a personalized demo of anything you've seen today, just submit a request as well at the demo link at the upper right corner. And if you'd like to get started with Parasoft Virtualize, you can download our community edition. It's available for free on our website. If you have any other questions, please do send those to us, and we'd be happy to follow up with you. And be sure to check our website for other great resources, such as white papers, case studies, and blog posts. Thanks, and have a great day.